Have you ever stopped to wonder how a program actually thinks? How your favorite app or game just knows what to do next? Well, I promise you, it's not magic, it's logic. And in this explainer, we're going to get right into the simple but incredibly powerful rules that let code, like Python, make smart decisions.
So here's our game plan. First up, we'll talk about why code even needs to make decisions in the first place. Then we'll jump into the 3 basic rules of logic. After that, we'll see how to actually put that logic to work with some real code, and we'll finish up by showing you why getting this down is a true programming superpower.
All right, let's kick things off with Section 1, Code that Makes Decisions. Before we get into the how, we really need to get a grip on the why. What's actually going on inside the brain of the machine?
I mean, really think about it for a second. How does your favorite game know you just landed the final blow on the boss? Or how does your calendar app know to buzz your phone exactly 5 minutes before a meeting? The answer to all of this comes down to a series of really simple logical checks.
And at its very core, it's actually way simpler than you might think. Everything, from the most complicated AI you can imagine to the simplest little script, it all boils down to asking questions that have only 2 possible answers, true or false. Is the player's health at 0? True. Is it 9 a.m. yet? False. This whole idea is called Boolean logic, and it is the absolute foundation of all programming.
And that leads us perfectly into Section 2, the 3 rules of logic. So if true and false are our building blocks, then you can think of and, or, and not as the magic words that let us combine those blocks into something useful.
Let's start with the simplest one of the bunch, not. Its job is exactly what it sounds like. It's basically a flip switch. It just takes whatever truth value you hand it and completely inverts it. True becomes false, and false becomes true. Simple as that. To put this in just plain English, imagine you decide, I'm going to go for a walk if it is not raining. See? Your entire decision hinges on the opposite of the condition it is raining being true. It's a really straightforward but super powerful concept. So this little chart here, this is what's called a truth table, and it's the perfect way to see the rule in action. As you can see, if the input is true, the not operator spits out a false. And if the input is false, boom, the output becomes true. Okay, next up we have and. Now this operator is the strict one. It's the bouncer at the club. When you connect 2 conditions with and, you are demanding that both of them, no exceptions, have to be true. If even one little part is false, the whole thing is false. Let's go back to our analogy. I will go to the park if it is sunny and my friend is free. Now think that through. If it's a beautiful sunny day, but your friend is busy, are you going? Nope. What if your friend is free, but it's pouring rain? Still not going. The only way you end up at that park is if both things are true.
And here's the truth table for and. Just look at it. Out of 4 possible combos, only one. That very top row where A and B are both true gives you a true result. This really drives home how strict that and operator is.
So if and is the strict bouncer, then or is its chill, flexible cousin. The or operator is happy as long as just one of its conditions is true. That's all it needs. It's all about having options.
For instance, I'll get a coffee if the cafe is open or I have my travel mug. So, if the cafe is open, awesome, you get coffee. If the cafe is closed, but hey, you've got your travel mug to make some at home, you still get coffee. The only way you're not getting coffee is if both of those things fail. You can totally see that flexibility in its truth table. Look how many true results there are. As long as there's at least one true on the input side, the output is true. The only way you ever get a false is if both inputs are false.
So let's put them side by side, because this is the key takeaway. And is strict. It's for requirements. Think, I need my keys and my wallet. You need both. Or is flexible. It's for options. Think, I'll take a bus or a train. Either one will do. Getting this difference is absolutely crucial.
Okay, moving right along to Section 3. If this, then that. So we've learned the rules of logic, but how do we get a program to actually do something based on those rules?
We do it with something called an if, elif, else block. You can picture it like a waterfall of decisions. The program starts at the very top with an if and asks a question. If the answer is true, it does something and then stops. But if it's false, it just flows down to the elif, which really just means else if, and asks a new question. And if all of those checks fail, it finally lands on the else block at the bottom, which is kind of the default. Do this no matter what action.
All right, time for what I think is the most exciting part. Section 4, putting logic into action.
We're going to take our little park analogy and see what it looks like as real, actual Python code. Okay, let's walk through this piece by piece. At the top, we're just setting the scene. We say is sunny is true, but, bummer, friend is free is false. Now the computer starts its checklist. It hits that first if statement and asks, is sunny true, and is friend is free true? Well, since the friend part is false, that whole condition fails. So the code inside is totally skipped. The program just moves on to the elif check. This one asks, is sunny true, and is friend is free not true? Well, is sunny is true. And since friend is free is false, not friend is free is true. So we have true and true. Ding, 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 we have a match. The program will print, nice day, I'll go for a walk alone. And because it found a path that worked, it completely ignores that final else statement. Its job is done.
And that brings us to our final and honestly our most important section, your programming superpower. Because what we've just gone over isn't just a random piece of code. It's a fundamental new way for you to build things. So if you take away only one thing from this whole explainer, let it be this. Every single complex app, every video game, every piece of smart tech you've ever used is built from these exact same super simple logical building blocks. It's really just thousands, sometimes millions, of simple true or false questions using and, or, and not, all stacked together to create incredibly smart behavior.
Mastering this kind of logic is the foundation for literally everything else you're going to do in programming. It's how you give your code a brain. So I'll leave you with this to think about. Now that you know how code thinks, what is the very first decision you're going to teach your program to make?